Hi, welcome to a new session of Circuits and Networks. In today's GATE exam preparation, we are going to see problems related to two-port networks. And this particular class, we are going to treat as class 1 under Z parameters, especially for two-port networks. So here you can see there are a few examples given, which was asking GATE 2005 and 2017. Let us go with the problem number one, that is for the given uh, network in the figure 1, we need to calculate the Z matrix. And this was asked for GATE 2005 in 1 mark. The options were given as A, which is the matrix of Z1, Z1 plus Z2, Z1 plus Z2, Z2, and B matrix is Z1, Z1, Z1 plus Z2, Z2. Similarly, the options C and D are given. So you should know exactly how to calculate the Z parameters by any approach, whether it is using equations method or whether you're going to directly employ the Z parameters concept to solve the problem. Anyhow, let us see how to find out the solution for this particular problem. So you should keep in your mind that whenever two-port networks parameters are given, you should know the standard equations for the given problem. For example, here we need to calculate the Z parameters. So this is the standard equation form of Z parameters, where you have the input voltages and output voltage, which is in the terms of I1 and I2. And the impedance parameters are Z11, Z12, Z21, and Z22 respectively. Anyhow, let us go with the actual approach of the problem. That is, we are going to employ the two-port method by making the port 2 as open circuited. So when the output port is open circuited, current I2 is 0. That is a basic concept. And figure 1, which is shown in this particular network, is reduced to the following figure 1A. So this is 1A. Here, remember, output port is open circuited. That is why I2 will be 0. And when I2 is 0, this Z2 is said to be an dummy impedance. And whatever the voltage measurement is there, that is V2, it will be across Z1. Anyhow, this is the figure what we have obtained from figure 1. Uh, by applying simple Ohm's law, we can easily get the value of V1 is equal to Z1 I1. And with this, we'll get the value of Z11 as Z1, which you can see in it is obtained in all the equations A, B, C, D. The first parameter is Z1 in all the cases. So this will not help us to get the final solution. Let us go with the next parameter, that is V2 is equal to Z1 I1. How V2 is equal to Z1 I1? Because V2 is measured across Z1. This I2, which is open circuited, and Z2 becomes dummy. Then, as I told you, V2 will be the measurement of voltage across Z1, and the current which is flowing in Z1 is I1. Therefore, V2 is equal to Z1 I1. With this, we are going to get the value of Z21, which is equal to Z1. Treating this equation as 2 and looking into the options, you may come into the conclusion that option D is the right answer. Okay, before finalizing your concept or before finalizing your approach, just go with the other solution also. That is, let us find out the other two parameters, that is Z12 and Z22. For that, when input port is open circuited, current I1 is 0 and figure 1 is reduced to the following figure, which is shown in figure 1b. So this is how the figure will look like when you open circuit the port 1. Okay. Um, when current I2 is flowing, V2 will be equivalent to this Z1 and Z2 are in series, I1. Hence, Z22 will be equivalent to Z1 plus Z2. Do you agree with this concept? Right. So anyhow, we got the option D, where you have the value of Z22 is equal to Z1 plus Z2. And the final approach to this problem is estimating V1, which is across Z1, and Z1 is carrying the current I2. So V1 will be equal to Z1 I2. Hence, finally, Z12 is also Z1. So undoubtedly, the answer is B, which is nothing but given in the option, and we got the actual matrix, impedance matrix in this form. So anyhow, if at all you are good at two-port networks, by the second equation itself, you will come to the conclusion that option D is the right answer. Anyhow, you have to be expert in getting the right answer, and for the proper solution we have derived the other two parameters also. So this is how you solve the problems related to two-port networks for Z parameters. Let us go with the next example, which was asked in GATE 2017 under Z2 for 1 mark. So here we need to obtain the transfer impedance Z21, that is also in ohms, and it is not a multiple choice question, it's a direct fill in the blank, which was for asked for 1 mark. Anyhow, the impedance parameters, as we have seen from our previous problem, is nothing but V1 V2 in terms of I1 I2, and this is the impedance matrix. Now in this figure 2 we'll apply KVL in this current shown directions. So this is treated as loop 1, this is treated as loop 2, and the top loop is treated as loop 3. And abruptly I have chosen the loop current directions in clockwise and anti-clockwise directions. You can have your own approach uh, pertaining to the direction of the currents which are chosen here in the figure 2. Based on that, if at all I apply KVL in clockwise direction for loop 1, I'm going to get minus V1 plus 4 I1 minus I3 plus 2 I1 plus I2. Why I1 plus I2? Because I1 is coming in clockwise and I2 is coming in anti-clockwise. So these two currents are superimposed over 2 ohms. That's why here it is 2 I1 plus I2 equal to 0. So reframing the equation, I'm going to get the value of V1 is equal to 6I1 plus 2I2 minus 4I3. This I'm going to treat as equation 1. Now assuming V2 to be at a higher potential, that is plus on this side and minus on the denominator, and when I'm going to apply KVL in anti-clockwise direction, I'm going to get minus V2 plus, now you see I3 current and I2 current are superimposed over this 2 ohms. That's why it is 2 I2 plus I3. Again same condition over this particular branch, that is 2 I2 plus I1 equal to 0. With this you're going to get the value of V2, which is equal to 2 I1 plus 4 I2 plus 2 I3. Now framing equations 1 and 2, let us frame another equation, that is I3. So applying KVL in clockwise direction to loop 3, I'm going to get uh, I3 equal to 0.5 I1 minus 0.25 I2 as equation 3. You please comment in the chat box whether you got the same equation or not, especially with the third loop. Now what I'm going to do, I'm going to substitute this 3 equation in 1 and 2. So when I'm going to take the equation 1, I'm going to get V1 equal to, you here can see 6I1 plus 2I2 minus 4, and I3, which is we have replaced the equation 3 over here. With this, I'm going to get the V1 value is equal to 4I1 plus 3I2. So therefore, Z12 value will be 3. Anyhow, similarly, when you apply equation 3 in equation 2, we are going to get V2 equal to 3I1 plus 3.5 I2. And our requirement is Z21. So here Z21 is equal to 3 ohms. That is the right answer. You can also solve this problem using actual two-port method, impedance parameter method, as we have done in the previous problem. Please apply the same method and comment in the chat box whether you got the same answer, that is 3 ohms or not. In the problem 3, which was asked for GATE 2000 for 2 marks, here directly you can see a two-port device is defined by equation, set of equations I1 and I2, which is nothing but 2V1 plus V2, V1 plus V2. Okay. Its impedance parameters, that is Z11, Z12, Z21, and Z22 are given by. The options are given here, A, B, C, Ds. So how to solve this particular problem? So from the concept of Y inverse, we can convert Y parameters to Z parameters, or Z inverse is equal to Y. With that approach also you can get the concept of Z in terms of Y or Y in terms of Z. Anyhow, what is this inverse concept we'll see here? Z is equal to Y inverse. So Y inverse will be given by 1 by modulus of Y, and you have to just uh, take the Y11 is replaced by Y22 and Y22 is replaced by Y11, whereas the transfer parameters are replaced by minus Y12 and Y21. So what Y actually we have, Y is equal to, from the given equation, standard equations, you can see it is in the form of admittance parameters. So Y equal to 2, 1, 1, 1. So this is actually the Y parameters from the given two-port device. Okay, now z can be obtained by taking the inverse of this y. So 1 by 2 minus 1 by 2 minus 1. Here it is 2 and this is 1. So 2 minus 1. So that is the determinant of this y. And y22, y11 are just replaced over this particular values. So this y22 is changed to y11 here. That's why it is 1 here and 2 here in the denominator. And y12 and y22 replaced by minus symbols like this. We have replaced from the given admittance matrix. With that directly we can get the value of z parameters, which is nothing but 1 minus 1 minus 1 2, which is the option B. These are the z parameters for the given pair of equations. So this was asked for a gate for 2 marks under gate 2000. So you should have a grip over the topic in order to solve these kind of problems. And for that, you can also see our previous videos related to two-port networks. So in today's class, we have done with the basic approach to solve the gate problems under Z parameters. I hope you like this video. Please share and subscribe to this channel, and please press the bell icon for the future notifications. Thank you.